In the 19th century, a scientist named Clerk Maxwell came up with the equations for the propagation of waves. This led to the development of an equation for the velocity of a wave, which is the frequency times the wavelength. In order to solve the propagation of waves through space, some scientists came up with a theory that the universe was made of a substance called ether. And in order to test that, they did this experiment called the Michelson-Morley experiment, which compared the speed of light in different directions. But however, they found that light was symmetrical, or the speed remained unchanged. This led to the development of the Lorentz factor, which is listed right here.
Looking at simultaneity, we talked about universal versus spacetime, and we've learned that spacetime is a single continuum. Furthermore, the relativistic factor can be broken down into gamma and beta variables. These are the two equations, gamma and beta. And basically, gamma is how length, mass, and time change for a moving object, and beta shows that the ratio of velocity to the speed of light.
Typically, when two objects are moving at a velocity and then the second object moves away from it, its velocity adds onto the previous object. However, this wasn't the case with light, and this led to the idea of a constant speed of light. And another equation that played a factor in relativity was the momentum equation, which led to the development of E equals mc squared, or the mass-energy equivalence. General and special relativity have been experimentally verified. There have been experiments in the past with gravitational lensing with a solar eclipse. Basically, they took a picture of the sun during a solar eclipse and they could see stars that should be behind it but appear next to it because of gravitational lensing. And with time travel, forward time travel is possible because of time dilation. However, traveling backward in time is not, because the arrow of time stays going in one direction.